behavior. Have we done anything with end behavior where we've drawn arrows to the right and to the left? Have we done that? Okay, we started it last time a little bit within a problem. In any case, I'm going to try and see if I can do the clarified version. So here it goes. If you're asked to find the end behavior, it starts off by drawing two arrows, one to the right and one to the left. So everybody draw that in. That's no big deal. When you get to do these other two by yourself, don't do these yet on the right-hand side. We'll do these together. Hopefully beginning it, not a big deal. I got my two green arrows. The next step is, those green arrows are kind of going to be in between, like wherever the picture is. Usually kind of draw it halfway in between so you can see, okay, half of the picture does something, and the other half of the picture does something else. The next thing after the green arrows are your blue arrows. Blue arrows either go up or down. The only question is, how do I know whether to draw it up or down? Let's say for this side of the picture, would I draw my blue arrow up? For this side of the picture, for those looking at home, would I draw my blue arrow up or down? And the way you tell, like someone's like, okay, I'm not sure how I can tell. This red line here is the line that all the arrows are talking about. When I go to the right-hand side of this red line, is the red line going up or is the red line going down?
So we read it from left to right?
You read it from left to right, at least initially. So everyone can see, hopefully, that as I go this direction on the red line, I'm going to wind up going uphill. No big deal. Okay. As I start writing the red line going to the left, am I going downhill or uphill? Yeah, downhill. It's no big deal. So let's put our blue arrow here. Now these arrows are not the final answer, but if you can put in your arrows, then you're like way closer to getting the answer because you know what you're looking at. You're looking at the red line. I wish you had a highlighter. Because if you had a highlighter, you could highlight that line. It's kind of like I'm making mine. Let me see if my arrows go up and down with my picture. Because what I want you to do me a favor, on the new picture down below, see if you can put in your green lines and your blue lines. Yeah, you might be guessing. Just do it in pencil. That way, if you have to change yours, you can. Again, hopefully my goal today is, yes, I know at some point I'm going to fry your brains. I'm going to try to give you as much as I can easy before your brain gets fried, and now after it gets fried, no new information can really go in that well. So I'm going to go standard 2. I want to back up to standard 1. It's a standard 3, and do one there. Then go to standard 1, which is the one where like, I'm just mad about that one. In any case, draw your arrows. Let me see if this will go up and down with me. No, it won't. Okay. We're going to need space to actually write down the answers. The arrows are not the answer, but they'll at least tell us how to start. All right, let me come around to you and put check marks on yours for the arrows on the 2 are nice and easy because of course they're whatever the picture is, you almost have to imagine it cutting it in half. And when you do cut it in half, just like here, 2 and 2. Some people had 2 and 1. You still always need 2 and 2. On the left side, what is happening over here? Anyone?
It's going down.
Going down. If you're writing this thing, you start, let's say, right in the middle of it, and you start writing this direction, you would write down. You got to imagine yourself writing on that one. And if you're going in this direction, is it up or down? And you really only have 2 choices. Either it's obviously going down, or this one. This guy here is inching up.
Does it matter where you place the arrows?
What I would say is, when I do it, for me, I try to, whatever amount of picture they gave me, I try to cut the picture right in half, and then that helps me decide what's going to happen. Yeah. All right, do me a favor now that you got to have the rhythm of it, even though these 2 are just about the same. Maybe just do the top one, and then the last one, once you've gotten that one right, it'll be for sure. Now, again, these are not the answers. You want to highlight this red thing. You would start right here. Now, another thing that we're going to see is that there aren't that really many choices. After a while, it's going to be kind of the same thing. The green arrows, that's a guarantee, so you don't have to think about the green arrows. The blue arrows, after a while, even if they give you another one of these, another one of the first one, Even with this one, there's not much else it could do. So here it comes. Down to the left, and what does it do to the right? All right, let's pause. Hey, Thomas, what's the actual answer when they ask me in the test for the and behavior? As a matter of fact, do me a favor, go to the top. Please double underline and behavior. Your graph is a red line. Hey, what's happening at the ends of the red line? How is it behaving? And here comes the answer. I'm going to start with this right-hand side, even though sometimes it may start otherwise, but it's fine. As the red line goes to the right, and on the number line, when you go to the right, you never end. Where are you going? If anyone knows that answer. I know the way I'm asking is all like,
The number line never ends.
yeah. Infinite is the answer. In other words, to say what direction you're going in, we use infinity symbol. It says, as I go to the right we call that positive infinity. First green line. What is the y doing? Well, the blue line is going up, up, up. And if it never stops, where is it going? Also infinity. Take a look at that and see if any of those make you wonder.
Y is the y-axis, right?
So basically, we're going up and down, we're using the y. We're going left and right, we're using the green. The green line going to the left, how do we write that? X goes to what? If you're going to the negative side of things. Yeah, negative infinity. So far, so good. Can someone tell me what y is going to go to? Yeah. So basically, the infinities are just the direction going in.
Thank you.
I
can't even.
Wait, why are you writing it down twice digitally?
Because the first time we're saying what happens when you go to the right. These two arrows. When we go to the right, it goes to positive infinity. The second time, you're doing the two left arrows. When you go to the left, what happens down there? Take a look at that answer and see if there's any part of it you want to ask about.
Can you say that again?
When the arrow goes to the right,
Okay.
the green arrow goes to the right,
Yeah.
the blue one goes up. In other words, when we go to the positive infinity on the right-hand side,
Right.
we also go positive infinity on the blue side. These two arrows are going the opposite direction. Hey, we're backing up to negative infinity, and it happens to go down to negative infinity.
How do you tell this? Never.
Yeah, so it's just the green. If you go to your right, you're going to positive infinity. If you go to the left, you're going to negative infinity. Say again? These here or these up here? Oh, good question. Listen to this question. The question here on when we write down the actual answer down here, why don't the arrows change? Look at this arrow's pointing to the right, he's to the right, he's to the right, he's to the right. Where on the picture, the arrows are pointing different directions. The answer is the arrows in the picture just try to describe what you actually see. The arrows down here actually represent the word approaches. As the x's approach infinity, the y's approach infinity. So here, these arrows aren't kind of the drawn ones up here. They're just the way we say, as x approaches negative infinity, y does as well. For those who are going to study their notes, for the purpose of these graphs, A, B, C, and D, if it looks like it's not crossing over the line, it really is. If it looks like it crosses over a little bit, like on the A, on problem A, it will.
What'd you say?
That is, if it looks like it really doesn't cross over the line, then it doesn't. But on some of them where it looks like it still crisscrosses the line, then it does.
So on C, it just touches it. Like it's like on the
Yeah,
top
so
of it.
yeah, it doesn't. If this does not obviously going to cross it, then it doesn't make it over. If it does go through.
So then do we use 0?
Whenever it doesn't cross, you have to use 0.
So it's going to be like the same answer as B, right?
All right, do this. I'm not going to have to check mark that one there, but do this while I'm writing down the answer for C. Attempt A. My hint to you would be write in all the infinities first, and decide which one of those infinities you're probably going to change to a 0. Yeah, we'll see. It's going to be tricky. I'm going to let you guess which one. So you're going to guess right, so you're going to guess wrong, it's fine. See, if you start off with all the infinities, though, you know at least 3 out of 4 are going to be correct. Or should be correct anyway. In any case, let me write down the answer to C. Do I want to, let's see, C. I'll put down my green first. As I go green to the right, I can see blue goes up. And that's why I draw in my little blue and green arrows to begin with. And behavior and up. Then that second line, I'm going to put in just the correct answer right away as my red, as my green backs up. It never crosses over that 0, but it does go down and down forever. So on C, yes, you're right, it's the exact same answer. A is not going to be the exact same answer, but at least start by putting in your greens and your blues, and we'll find out who turns into red.
How do you know which one you changed?
That's the tricky part, and that's what I'm trying to show you.
Oh.
My hint is going to be, well, I don't have a hint. I guess looking at the picture.
So it's always going to be the third one, or no?
No. You'll have to really think about it. Like here, I knew it didn't cross over. The green arrow couldn't make it past this line, so I wound up being the left green that got changed. If we were going this way and it didn't cross the line, then I know it'd be the right green. If we're going down.
So you always start with the ones that go left to right first?
I do.
Okay.
All right, here we go. Problem A. Let's see who got lucky. Well, we know if I did the green over here, no big deal. I can see the green goes to the infinity. The blue is going up. That looks good so far. All right, let's try the green going this way. Green is not stopped off. I see the stop sign here. Well, it's okay. So green looks like it's going okay that way. Green going to negative infinity. So he seems okay. The Y that's trying to go down never crosses below this line. This line here stops it. It's sometimes called an asymptote because it approaches that line, but it never gets there. So it is the Y that does not go below 0. The Y turns out to be the one who doesn't go below 0. Did anybody guess that one? The
No,
Y?
you got it wrong.
Oh, really?
All right, so we got 2 who guessed that one. Take a look at it though and know, because you already have to know which one has 0.
You did?
Yes.
This dotted line I'm putting here, based on the picture, as the red comes below, it doesn't cross through it. It kind of comes down and it's coming closer and closer. It's an asymptote. It's a line that the red line approaches, but it never touches. And the coordinates of that line is a 0. In other words, whatever line you can't cross over, he gets a 0. The question is it an up and down, or is it a side to side? Like, look at this. This is a side to side. When you go to the side, it doesn't touch. This is why standard 2 messes up a lot of students. Pause, see if you want to ask any questions about the answer to problem A. He's a famous one. That's why there's a star on him.
So 0 is always going to be the one that's very near to the line.
Yeah, I'll say it for this case, so it can be simplified. All right, let's for you. What's that? Right down there. Write down the following. We standard 3. The problem is y equals negative log -4 times log x. Instructions are to solve for x when y equals 8. All right, I'm gonna let you guess a little. Say that. You have to do something. You got to put this 8 in a certain place before you can start doing the problem. And the hint is going to be. That one sheet that had all the logs going down the middle. This is going to be like the top section that we saw in there with an extra step. So if you need the second one. All right, here we go. Step 1, where do I put the 8? Someone, please.
-8.
So where am I going to put the 8? In the place of what? In the place of the y. Someone else? Someone different? Tell me what to do with that -4. We got to get rid of that. Close. Close. We are going to do something with that -4. We're going to divide it. This is -4 times log x. The inverse of multiplying is what, someone?
Division.
We get our -2. We have our log x. And here comes the first thing that they expect that might trick someone. Besides that 4 thing, that was no big deal. What is the base on log x when no base is written? 10 is it.
Why is it 10?
It's just the rule. So like, what exponent do you put on an x when there's no exponent there? Oh, it's automatically a 1. There's an official reason for it. But you have to know that log x is log base 10 of x. The only way it's another number is if they put it there. If they put a log base 2, okay, it's log base 2 of x. All right, let's see. So we're doing this one and the next one up. All right, so the next step. We need to change this into exponential form. Okay. Can someone say how to change that into exponential form? Say it again. In other words, what she's saying is write the base and switch. Write the base and switch. And so what we wind up here is the 2 winds up on the 10. The -2 winds up on the 10. And the x winds up on the other side. Let me pause there so you can look at that. All right.
How did you get that?
So again, and everyone needs to punch this in into their calculators, because if you don't punch it into your calculator now, when it comes Wednesday, yeah, you have an answer out that just popped up on the board, but if you don't punch it in, yes.
How'd you get that?
Punch this into your calculator.
10.
10 to the -2 power.
Oh, that's it?
Anybody else? I'm about to come around and check calculators. Now, if you're writing something else, I get it. You're trying to get some other stuff done, but definitely punch this in so it's in your brain. Let me come around and check your calculator. All right, here we go. Give it another shot. This time, see if you do it on your own as if you were taking a test. And then at the end, obviously when we do it together, solve for x. You can put it in blue to remind you why it equals. All right, give that one a shot. Again, you're still in standard 3, and hopefully you'll start to see it. Okay, I see why he expects us to get standard 3. Keep going. All right, someone say step 1, please.
Divide 6. Oh no, you plug in the.
Yes, that one is just plugging it in. That way you have that. Someone say step 2, please.
Divide 6.
All right, someone different. We're going to go for the third step. Someone say what the base is on the log, please.
10.
10. All right. And again, you can see again why the Common Core does not like what I'm doing. I like the fact that it's nice and smooth for you because I want you to get your credit. Oh, by the way, for it seemed like a long time ago we started, but here we are, not at the end completely, but close enough where I can say, look at this, you made it. All right, we're going to change this to 10. We're going to write the base. Always write the base first, and then switch. Base and switch. That alone, if you can do that, you're writing it from log form to exponential form. Exponential form may say there's something raised to the power, but there's no word log. All right, that last move. What did we get? I saw it on papers. 3.1. I'll take it this way. If you went further, I'd recognize you're not going to get whatever. Take a look, see if you want to ask something. There you go. Pattern of logs. Let's see what we got here. Log base 2 of 2. Oops. E of 2. We'll see who guesses. Anybody know what this equals? Well, let me say what the question is asking. Then you can guess what this equals.
4.
This asks the question, what power do I need to raise 2 to so that it will equal this 2? What power do I need to raise the green 2 to so that'll equal just a regular 2?
1.
1. I'm going to write the answer over here in red, but I'm going to put in a circle. I could put equals 1, but for now I just want it to be a 1. I want you to know that if you saw this expression, it equals 1. Let me try a second one. The second one looks a little different. Well, I'll let you write it down. It looks exactly the same, basically. I want the third one to look a little different. So let it look the same on the second one so they can feel good about themselves. That's what you do in education. You present something. You do something just like it. A kid feels like, oh, okay, I get it. And you switch it on them so they can feel bad. It's unfortunate. That's just the game they play, and I'm just a pawn in the game. All right. Can someone say what log of base 4? Someone who didn't answer the first one. Log of base 4 of 4 equals
1.
Yeah, 1. Okay. In other words, what power do I need to raise the green 4 to so that will equal the regular 4? Oh,
1.
4 to the 1 power equals 4. Let's try one more, or actually 2 more, but let's see if the pattern continues. It may change, but let's see. Log of 10, write that down. My hint to you will be write in the missing green base, and then write down what it equals. So for this one, this is the way they will normally write it. They won't put in that missing green base that you're about to write in, but they want you to know what this normally equals, even if that missing green base is not written. Okay. Here it comes. Someone tell me what the missing green base is. And someone different who answered, tell me what this equals.
1.
Yeah. There is a pattern. We're going to use it in just a moment. Here comes the tricky part. The tricky part is what happens if this was written. You may not even know what it means. But I do want you to write what you think. That answer would be log base E of E. What does that equal? Don't say it yet. Give everybody a chance to write it down. It looks similar, and hopefully that's what the pattern part is. For Common Core, this goes under, where is that? Reason. Yeah, all the way at the end, number 8. Look for an express regularity and repeated reasoning. In other words, see if there's a pattern you can find. And you put that. All right. Can someone say what the answer is going to be?
1.
Yeah. Anybody know what actual number the letter E represents? There's an actual number. Like pi, equals something, 3.14. But E represents something. No, it's an actual number. It goes on forever and ever, but.
3.3.
Oh, I get to share it. That's cool. I like this
I remember you said, but I don't remember what it was.
It starts with the number 2.
Oh, I said that.
Yeah. E actually equals 2.718. That way, if you ever see it in a class somewhere, a teacher puts up the letter E, you will be able to answer and be like, oh yeah, it's 2.718. It goes on and on forever and ever like pi. That E, what it equals, isn't the important part. What is the important part? If ever you are given a number and you want to cancel out that number, if you do log to the same base, it cancels it out. It turns it into a 1. So if I see an E here, I need to get rid of that E. I do log base E, bang, gone. If I see a 4, log base 4, gone. So now that we have that, let's actually give you the problem as you will see it. Pretty intense. Get ready for your brains to be warped. Let's see what we got here. All right, here comes some. This is still standard one. It begins like this, 7,500. Let me write that in blue to see if it reminds you of an old problem we did. I don't know if it's going to turn out the same way, but at least let's make it look similar. Time equals 750. Here comes that E that I was talking about, times E raised to a decimal. Good thing you guys have calculators. 0.057 times T. Look at this thing. The question is, what are they asking for? Solve for T. I'm going to let you, like Common Core style, mess around with it, see what you think you might do. My hint is, you have to do something with that 750 to begin with, and then it's going to get ugly from there. My hint also will be, for this problem, on that log sheet, it actually will go with the top section. So 2 hints. You got to mess around with the 750 first. The log base, see, this is the problem, is a mess, but at least it's going to look similar to the top section when you have to start guessing stuff. And again, on these, I sent out a notice, I don't know who gets the text, but it says, start looking, All right, hey, someone say out loud what to do with that 750.
Divide.
Divide that guy on both sides. The reason we have to divide on both sides is when we're trying to get to a T that happens to be in the exponent, you can't have any extra numbers. You can only have a base and the stuff floating in the sky. If there's something in front when you try and drop that log, it creates a problem. So here we go. 750 was what? Came out to 10? Was that 10?
Yeah.
All right, we got our 10. Over here it equals this E stuff so far. Hopefully it doesn't feel too bad. And that's my goal as a teacher. Whenever I'm explaining, just hope it doesn't feel too bad. Here comes the next step. I'm going to rewrite this so that it's not on the same line. In other words, when you have notes, if a teacher puts 2 things on the same line, you sometimes can confuse some students, like, where did we get those 2 logs from? I want you to know that step 1, we just got rid of the 750. Here comes step 2. To get rid of this E, can someone guess what we're going to write in front of that E?
2.71.
Not this time, that's what it's equal to, but not that. I heard someone else kind of sort of saying it.
Log.
Remember, to get this T down, which is what we're trying to do, is a balloon. It's floating up high. We tie a log onto it. So we would tie it on, and it would look something like this. We tie a log on front here. Whatever you do to one side, you must do to the other. Here comes the big, big question. What does the base have to be on this log so it will cancel out with that E?
10.
E is going to be at 10 if this were a 10 would be the right answer. Whatever this one is,
1.
Is automatically what it would need to be. Let me put it in blue. This is the part that will mess up some students. Because you're getting it, and you're going to put a star in this problem or review this problem, it doesn't have to mess you up. Here's what's going to happen. These logs turn into a 1, leaving you with just this 0.057 times the letter T. On the left side, though, we don't know. This is an E and this is a 10. There's a problem here. How are we going to punch this into the calculator? Now, some people want to just hit the log button, but no, this is base E. When you just write the log button, that's a base 10. Here comes the answer, and I didn't want to say it until now. It turns out to write log base E, there's a special way we call that. It's called the natural log. The natural log on your calculator is there with 2 letters. There's an L for log and an N for natural. See if you can find where that LN is on your calculator. Okay. Whenever you see that LN, and that's how I'm going to rewrite this line here, that means the same thing as log base E. Too much information, but I'm writing it anyway. Let's see if someone can handle this. Ln of the 10. write that down and draw an arrow so that your brain knows that whenever you see log base E, it's written as ln. If you ever see an ln, you know it's just log base E. All right, so okay, thank you, but now, is that the answer? No, now you can do it. In your calculator, do ln of 10, and somebody tell me what that equals. I'll write it right below it.
2.305.
2.30.
Whoa.
Yes.
I'll just go with 2.3. If I saw
to close it. That's just to
okay, and if I saw something else with extra numbers on there, do that. So even on this one, punch that ln, and that way you know where it is and see what it looks like. And guess what? After all that work, you're left with just a baby division problem. The baby division problem says, how do I solve for t when it's 0.057 times t? And there's another number on the other side. Am I going to add, subtract, multiply, or divide over here? Yeah. I say this one towards the end because imagine me doing this one at the very beginning. There's a bazillion steps, which would have used a lot of brain power. I decided, well, let me draw arrows up and down. Students can draw arrows up and down. Then let me go to the next one where they divide that 8 in the place of the y. So let's see here. They divide this 0 point. Hopefully some people can see why standard 1 is second in line. Standard 3, not too bad. Standard 1, problems like these that are extra long, a lot of places to mess up. Oh, thank you, not the T. Sorry, no T down here, but a 7. All right. Someone say what that final number is?
I know. 40.350.
I heard 40.35.
Yeah.
40. Or 40.4.
If you put extra, if you rounded that, that's fine. Take a look at it. I'm going to go back through the steps now that we have them written. See if I can get standard 2 and a standard 1. That last standard 1 might be tricky, but you have an example of it. Step 1. Hey, I got to get that red T down. Get rid of that 750 first. That's what we did first. We got rid of that 750. When we divide on both sides, we wind up with that. Step 2. How do I get rid of an E? I rewrite log in front of it. Same base turns it into a 1. And then from there, what we do to one side, we must do to the other. That's why we did this log over here. Hey, Thomas, where did you get this ln thing from? ln is natural log. It's the name of log base E.
Are you trying to make your stupid awkward?
Once you got that, you work it out by doing the log. Just do it in your calculator. Log, natural log of 10. You punch ln in 10. Turns into 2.3. From there, the last step is, hey, how do I get rid of this number from in front of the t? I divide it on both sides, and I get my final answer. A lot of work. If you don't review it, I don't know if it's just going to be there for you on Wednesday. All right. All right. Let's see here. Step 1, we have to write an equation. Step 2, we need to find the intercept, which is the y-intercept, which is easy. And step 3, those arrows, we have to draw it on there. I'm going to draw the arrows, but probably not writing the answer, because again, it's 2 green arrows, 1 up, 1 down. You actually have those arrows on the other page. 69, it's a single page. Here we go. Step 1, you got to write down the formula. This formula you will need to see at home. That formula looks like this. Y equals A. If you know what letter comes after A is B. And then an X floating in the air. The deal on this one, and again, in some of your other notes from last class, we went over which number is probably going to be the A and which number is going to be the B. The B is usually a percent. So does anyone know what B is going to be in this problem? 3.2%. I'm going to circle that and put the letter B next to it. If B is that one, A can only be one other problem. The X and the Y, they don't change. The 5 billion, which we're just going to use, I'm going to use a 5. I don't know that it'll change it. We'll just know it's in billions. Circle the 5 and put an A next to it.
So you go about putting names.
Yeah, so no big deal. You're putting together a puzzle. The only two pieces of the puzzle are A and B. The B, if there's a percentage, will always be the B. The A, if there's a money problem, the A will be the money, or in this case, the other guy. So basically, if you find one, you automatically have the other. Hey, how do I write out the equation to try and get me at least 1 point on this?
Y equals 5 billion times 3.2.
Almost. Yeah. 3.2. No, you're right. Except, even though there's going to be a twist, I'm going to put in that 3.2 and I'm going to change. So you write with a pen. I'm going to put it in just so you can feel what it's supposed to look like to begin with, and then we will fix it. What does he mean? What does he mean? If I put in that 3.2 in the place of B, I would say, okay, at least you're in the right direction. You know what you're trying to do. Does anybody remember what we have to do with that percent from last time?
Good question.
Yeah, at 1.1. Wait, 1.6.
All right, he knows it has to do with a 1. That's going to be important.
1.1.
All right, let me do this part, and I'm going to take questions. Don't forget it, though. Okay. The rule is this. When you have that percent,
I don't know, is it 5 or is it 5?
Isn't it
You can just put
1.115?
You don't need to worry.
So I'm going to put 0.
if you have the percent step 1, you have to change that percent into a decimal by moving the decimal point 2 places to the left. Cross out 1, 2, how I say 1, 2. You went with 0.032. And then as we did last time, for these type of exponential problems, if it's a growth, you have to add a 1 in front. If it were decay, which it won't be in this case, you would do 1 minus the 3.2. So in this case here, it's 1 plus. So what goes inside this this parenthesis? 1.032.
Wait, why is it a 1 point?
It's just the rule we went over last time. And so you just got to remember that if it's one of these, so what just happened? We put in the percent the way you would normally think, but because of last time, and what you'll have to review in that video, there's no other way around it. If it's one of these, you want adding a 1 in front of it. If it's a growth. Do you see that word grow?
Yep.
You know inside is going to be percent turned into decimal plus 1. If they say decay, it'll be percent turns into decimal, 1 minus that. But for now, since they aren't going to be one of those, we'll just stick with the grill. Pause. Here is the formula. The question is, hey, how do I sketch a graph of that and then get an intercept? Anybody remember what we did? Who was going to be the y-intercept between these two numbers? I know last time, it was a long time ago.
5.
Yeah, if there's a number in front of it, it is going to be that 5. So here, I'm going to put y-intercept, and I'm going to draw that picture. I'm going to draw an arrow here. I'm going to put y-intercept. And I'm going to put the 0, 5. If today's your first day, it's going to be a lot of information. But if it's from last time, some of it should ring a bell. How do I draw the picture? It is an airplane taking off, and the airplane has to go through a certain number. What is that number?
Oh, you say there's no difference.
That's 0, 5, and put it right here. Oh, well, this one has, you can get the 5 on this one, so I might can't put the real place on this one. 1, 2, 3, 4, 5. Okay, and here comes the airplane. It's taking off. Starts on the runway. Goes up, 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 up. You've just gotten 2 points. What are the 2 points that you've gotten? 1, you've written an equation, and then you sketch the picture. Second point, what are the intercepts? In other words, where does this green arrow hit the y-axis? So it hits it right here, 0, 5. You've just gotten 2 points. The last point in this section are the end behaviors. What are the end behaviors? Well, I'm going to draw the 2 arrows for you. It's about halfway here. On the right-hand side, is this thing going up or down? Yeah. See? No big deal. Left-hand side, up or down?
Up. Oh, I was just saying that.
So again, as long as you can split this picture into 2 pieces, anybody can draw those 2 out arrows.
Yep.
And the blue guys, either they're both gonna go up, both go down, or usually they flip one up, one down.
Yep.
My only hint as you write the end behavior at the very bottom of the page is going to be your hint here. This green line will not go below a certain number. That airplane taking off will not go below that line. So this second blue line, I'm going to give you a hint because you know there are going to be 3 of them that are infinities, and one of them will be that 0. Write in the answer on that. I'm going to write down the second. And then I'm going to just start one from last bottom.
The second one?
Yeah.
So the only new part on this problem was writing down the equation and finding the X-intercept.
Yeah, so the line.
All right, here come the end behaviors. The guy who went to the right, his friend also went up. As the green arrow went to the left, the second guy, which I've written him in a different color, that Y, which I'm going to write in red, could not go below 0. The second blue guy. I always start with the right-hand side of it, because that part is usually the easy side. It's this left side that usually has some problems. All right, the last one I'm going to try and write in for you. Let me pause it and let me say it. Anybody have a question on this one? Where'd you get a number? Any numbers that are up there floating on like, whoa, where'd you get that number?
I thought it would have been an X instead of a Y.
This is standard one.
Where
For the
this
zero?
is standard 2.
Because the zeros on the X
I think
axis.
I'm in.
This 0 just represents the blue. In other words, when I'm going in this direction with the green, is it then going up or down? Well, the blue is going down. That's the arrow going
Is it
down.
on the X axis, not on the Y axis?
I know what you mean, but my answer has to be the green guys represent the x-axis, the blue guys represent, whether it's going up or down or the y-axis.
So when do I know when is the 0?
If there's a line it doesn't cross, you see how this line here? If it doesn't cross the line, that's when you know 0 is going to be around somewhere. It crosses through the line. Yeah.
My question was how do I know which one is
Oh.
out of the 4?
Because the greens, usually they're going to be the infinities. And this is tricky. That one sheet that we did, use that one sheet to look at the 4 examples. And your picture's going to be one of those 4 examples. Either it's going to be arrow taken off or going down. And so basically, look at those 4 examples. But it is tricky. You are right. I wish we had 5 of these in a row and go, oh, I see it.
Because
But
the pictures don't have colors.
yeah, we don't. All right, let me squeeze in this last part. The last part. Turn to what page is that one? It has IB. It's on the same thing. IB.
Page 71.
71. I'm gonna write. I'm just writing now. You're just copying so you can have the example, and you can look through it. But what you're gonna see is gonna look like this is standard 1. Please write what standard it is. Hey, when you go home, if you were me and you were studying for this test, how would you study? You would double study standard 3. He's your friend. Then back up to standard 1, and then standard 2, which is the cow. For some of you, can go either way. There he goes. Hey, Thomas, get this answer to this problem. The loudness is measured by whispering. Please circle the 1,000. This one I'm not asking you a question. I'm just going to put it in. Circle the letter I.
So I can be whatever.
It will be the 1,000 that they gave you. When you read the problem, you're going to substitute in, and it's going to say I is sound intensity, and they tell you that up here, that 1,000 is sound intensity. So they're going to just give it to you. We did one of the, oops. So let me just write it in, and then you'll have it as an example. You will have one that looks similar to this one. We're trying to find what dB is. It's floating up high. So how do we get rid of that 10? We did it in just the problem before. This problem is going to end super fast. It's almost done already. Almost done already. Hey, what's the base on this green 10 if you want to get rid of this 10?
10.
Mm-hmm. I should say green log rather. Hey, what did we just do? I want to get rid of a 10. I wrote a log with a 10 hanging below. Whoosh, they cancel out. Let me see what's left. What's left is this, which is the point of it. We want to get rid of that, all that stuff there, so it leaves us with just this here. Your job is complete to understand this one right now as much as it will be to have an example. Step 1, step 2. Someone in the comment hit log 1000, so I know what that equals. On this side here,
What'd you say?
log 1000. Uh-oh. Sorry. Look at this, I made a mistake. Here's a mistake I made.
3.
All this stuff here disappeared, leaving me just this. All this canceled out and became a 1. I made a mistake. Let me write down what it should have been. Just the dB over 10. All this stuff disappeared, became a 1. So we don't need that.
Okay, we have to divide it by 10.
What did someone say was on this side? No, we won't have to. We're going to multiply it. Anybody think hit log 1000 real fast?
3.
Okay.
Wait, what'd you say?
That's correct. 3.
Thomas is a TV divided by 10. The
Uh,
power.
No. So it was the power,
Okay, just want to make sure.
but because we did all this stuff here,
Yeah.
it made all this disappear, and now we're just left with the dV over 10.
Just want to make sure because I didn't know if it was a normal number or if it was.
Okay,
TV is
good.
30.
Did you want the other log or actually log 10? Or
Just a regular log, because regular log is automatically log 10. All right. How do we get the next step? We're at the end. We're dividing by 10 on this side, so to get the answer, just like Roland is saying, I'm rewriting the line so that we can have it twice.
Yeah, 10. Oh,
We multiply both sides by 10, cancel on that side. Final answer. 30 on this side. They cancel on this side, leaving dB. Did it go fast? Yes. Are the steps there for you to go through one at a time and put a question mark so next time? This might be one of the ones that we look at. Yes. But the most important part, you have something in your notes to look at.
Sounds like I can't see.
Oh,